Good evening, everyone, and welcome. My name is Ingrid Schwarzkopf. I'm a recruitment officer here at the Faculty of Applied Science and Engineering at the University of Toronto. This evening, we're going to be highlighting the electrical engineering program here at the university. And this evening, I am joined by Shreyas, who is a student here, and Professor Draper, and they're going to give you an insight to the program this evening. For those of you that are new to learning about the University of Toronto, we have an engineering program that is world-renowned for our leading-edge research and discovery. So really, regardless of the program that you choose, you will have access to U of T's top-ranked professors like Professor Draper, and as well as the curriculum that is consistently evolving. Also tonight we'll have the opportunity to really dive on into learning a little bit more about the degree and what it offers and how you can tailor your academic courses, your minors, the certificates, and the internship opportunities, and really get to hear more from a professor and student perspective versus a recruiter's perspective. So without any further ado, I'll allow Professor Draper and Shreyas to introduce themselves.
Hi, my name is Shreyas. I am in my third year of ECE, and my focus is within communication systems, networks, and computer hardware. I'm also working towards my engineering business minor and working towards my certificate in engineering leadership as well. This past summer, I worked at National Instruments. It's a company down in Texas, and I'll be going back there before my final year next year.
All right. So my name is Stark Draper. I'm a professor in electrical and computer engineering, of course. My work is in communications and learning systems, so I basically do the math that makes your cell phone work. And I also study things like how we make machines gain intelligence, how we make machines work better. I did my PhD at MIT, my undergraduate at Stanford, and like lots of faculty in our department, and more broadly, I have lots of industrial interactions. In the past couple years, I've worked with Mitsubishi Electric, Disney, actually as a research lab I work with, and Analog Devices.
Great. So it sounds like we're going to have lots of interesting things to talk about this evening. And to start off the evening, Professor Draper, a question that I always get asked on the road by prospective applicants is, what is electrical engineering? What am I going to learn? What does it entail?
Sure. So, kind of, I guess maybe one way I like to kind of think about these questions is a little kind of historical perspective. I was actually a history major as an undergrad. So if you kind of think where our departments came from in the 19th century, there were two killer apps. One was the electricity grid, and one was the telegraph grid. So what electrical engineering departments were founded to do was to kind of apply the laws of physics and the laws of information. So in those cases, it was originally energy systems and the early digital communication systems, the telegraph. Later on, we got computing systems and things got even more broad.
Great. And Shreyas, why did you get into electrical engineering?
Well, when I was in high school, I always liked the idea of building things. Okay. And engineering seemed like a place where I can solve problems and build things in one program. So I just got interested and now applied here.
Yeah, great. And now, did you start off in the EC program when you entered first year?
Yes, okay. I started off in EC and stayed. Great,
so you really knew what you wanted to do right off the bat. Great. Now, maybe, Shreyas, you can tell us about the opportunities, and maybe Professor Draper can kind of chime in too, and tell us about the unique opportunities available to electrical engineering students.
Well, speaking about the program here, I would say there are PUI is one of the biggest opportunities that we have. PUI is our professional experience year, which is basically like a co-op, but for a longer period of time. So you get to work on a project for a longer period of time. That's one of the biggest ones. Other things that I really like about this program is the minors. We have, I think, several minors. I'm doing the engineering business minor.
Yeah, you're doing the business one. Maybe you could tell us about how you've found that minor so far.
It's excellent. It gives me an opportunity to explore a completely different area that's outside of engineering, and it gives me an exposure to something that's not just like in the engineering faculty. Yeah. In general, I would say like the other minors are also really interesting. For example, the biomedical engineering minor.
And now, have you found your business minor complementing the type of work that you've been doing at your internship?
Definitely, yeah. So the business minor I've come to, well, I've kind of explored different areas within the business field.
Yep.
I've seen from marketing. I've seen things from marketing, from people management and organizational behavior, and those kinds of skills and those kinds of concepts that you learn from that area definitely helps in like not only just my jobs, but like
Yeah.
any job that you get in the market or in the field.
Totally, and I mean that's one of the great things about our program here is the flexibility you have to really combine even a business minor with an electrical engineering degree, right? So, Professor Draper, do you have any other, some unique things that your students are currently working on or opportunities for your students?
So we're, yeah, I guess I'd say like one of the things that is very nice about the curriculum here is the design aspect of it, right? So kind of about building off,
Yeah.
building things. The design curriculum, I'd say, kind of broadly across the Faculty of Applied Science, electrical engineering, computer engineering, and all our departments, has a strong theme, a strong emphasis of design, where you work in groups. You kind of learn how to take a big problem and break it down and sequence little chunks to solve them and present your results. So I think that's something that students experience first in their first year design course,
Absolutely.
and then at the end in fourth year all students have to do a full year design project with somewhere between 2 to 6 students that they work and they work in conjunction with a faculty member.
Yeah. Now maybe you could touch on some of the areas of focus that the students have, or maybe even stepping a step back further. For the audience, the computer and electrical engineering actually start off together, if I'm correct. So maybe you can touch on how that's a benefit for our students and how it kind of breaks down when they get into upper year. Maybe Shrez, you could chime in and give us your story of how you've ended up where you are too.
Who do you want to?
Shrez, you want to start?
Sure,
Yeah,
I
alright.
can start. So at the beginning of the program, we electrical and computer engineers start together,
Yeah.
and they form a base of knowledge that's I think needed for any engineering discipline. We learn about everything from like photonics and semiconductor physics to computer software or programming, and this kind of gives us an idea of different fields within electrical and computer engineering, which are really similar to one another. So it kind of complements what we learn. Like from one, if we learn something from one course, it definitely complements something that we learn in another course, and that's really great. So in the first 2 years we do that, and then in the third and the fourth year we get a choice to specialize within either computer or electrical, and there are I think 6 different. There are 6 different fields or streams that we can specialize within, and from the things that we learned in the first 2 years, we get an idea of what we like. So in the third and the fourth year, we can choose the areas or choose the programs or courses that we like
Yeah.
within the streams that are available. So like it's anything from photonics and semiconductor physics to energy systems, communication systems, networks, computer hardware, and computer software.
And remind me again, which one was it that you?
So I'm doing communication systems,
Okay.
networks, and computer hardware.
Way everything beyond me, but yeah, sure. And Professor Draper, anything to add to that?
Yeah, so I think that was quite a good summary.
Yeah.
So generally, in the first year, the EEs and the CompEs are together, and they kind of set the foundation for all of engineering.
Yeah.
And maybe one thing to add there is that that's one of the things about the faculties, because across the different departments, there's a quite similar first year. People can transition between different departments pretty easily. So we have a small amount of motion, and then we also have this general engineering first year, what's called track 1, that people transition. And I think actually historically, most of those people come into this department, electrical computer
We
engineering.
do tend to see that, yes.
And then in second year, we try to set the foundation. So kind of building off what I said earlier, where kind of EEs, electrical engineers, are kind of think about applying the laws of physics and the laws of information. One of the things about computer engineers is they try to take the things that EEs build and assemble them into larger, richer, more complex systems, be they networks, be they computers themselves, or larger systems. So there's kind of that kind of design,
Yeah.
and that's really happens in the third and fourth year, depending upon what you've decided you're most interested in. And maybe you learn that both from your classes, and also like we go in the second year, There's a course, 201, something like that, everyone takes, where you have faculty who come in and tell you, okay, you know, in third year, this is one stream of concentration courses. So I go and talk about the information and communications courses. Other people talk about computer architecture. And so then students both in those classes and then kind of in their classes in second year, and then through these presentations kind of see what the trajectories might be.
Great.
And one thing I wanted to mention, this kind of a program definitely helps us it gives us a competitive edge in the market later on, because we have
great.
knowledge from both like the electrical engineering discipline and the computer engineering discipline. And then we can focus on what we want later on in upper years.
It's funny that you say that, because that was going to be my next question for you. Is there a competitive advantage to having both? But it really seems like there definitely is. And now, Professor Draper, what kind of research opportunities would students be looking at in their upper years? Perhaps they're for their capstone or research components.
So I guess let me maybe kind of make a distinction between
Yes.
those two opportunities. So first about the research.
Yeah.
So we have, I don't know, about 79 faculty, I think, right now in the department across electrical and computer engineering, and something around 400 graduate students. So there's and 80 postdocs. There's a big, a very large research initiative. It's the largest ECE department in the country. And so there are lots of undergrads who work in the summers. And one of the federal funding agencies, NSERC, the National Science and Engineering Research Council of Canada, they provide scholarships for students to work with faculty in the summer, and you have to apply for that. So I just put in an application with the student last week.
Oh, great.
And so, you know, the student approached me in my second year class, and we kind of talked about a project, and yeah, they seemed to be a nice connection. So again, kind of like many things in life, kind of being proactive and talking with people, you know,
Definitely.
it's not necessarily that every faculty will have a position, but you know, you have to ask. So that's so there's lots of research opportunities for undergrads. And actually, speaking about students who might want to go on, if you are in your second year thinking about going on to graduate school, one of the things that makes you your profile most attractive to people who might hire you is if you've actually already worked with a faculty member who can write about your contributions, your creativity, and maybe even have a research publication. And so you see the very strongest students who are interested in going on do that. And then on the other dimension, the design project. So in the fourth year, we have a senior design project at Capstone, which is a full year with about 3 to 6 students, and you work together under the supervision of a faculty member. Can be a student design project or student chosen project, can be a faculty chosen project, or it could be an industrial project where you have an industrial partner. And I've supervised all 3 of those, where the students came up with a project where they approached me and said, hey, we're interested in your area, do you have a project? And another one, we had an industrial sponsor. So those kind of are all in the mix.
Now, Shreyas, are you planning on doing a capstone project?
Yes, it's actually a requirement in the program.
Perfect.
So I am doing one next year. I do have a team formed for
great.
the Capstone Project, but I will be looking through different projects. There is a listing online, or we can even propose projects, and I will be doing that this
Great.
summer and next year.
Professor Draper might even be your mentor.
He might be.
Yes, you never know. Great. Now, in addition to the research, and Therese, you kind of touched on this already, if you can kind of touch on the professional experience year component. And again, for our audience, the professional experience year is an optional internship for all students after they completed their first 3 years. And then it is paid. The average salary is $50,000, so it's nice to be able to get a little bit of money. I'm sure Therese can attest to that. And maybe Therese, you can give us a little bit more about the type of work that you were doing, and you're going back, so I mean, you must have really enjoyed that opportunity. And maybe you could share with us where some of your other friends have went, or I'm sure Professor Draper might have some insight on where some other students are doing their PY opportunities.
Well, I worked for National Instruments in Austin, Texas,
Yeah.
and I worked as an application engineer.
Okay, great.
I worked with the product marketing department, and I know that sounds kind of different because
Yeah.
I'm an engineer and I was working in the product marketing department, but that's really common.
Okay.
I think being an engineer, we learn such a wide variety of skills that employers look for, that it's strange how many different fields that we work in, or how many different sectors we worked in.
Yeah.
I worked in basically an electrical engineering company.
Yep.
But I've had friends that worked in banks, federal agencies, or even national defense.
Oh, wow.
So that was really cool. People also go on to work with OPG, Hydro One,
Yeah.
and
Lots of opportunities.
Very, yeah.
Sure. So I brought this nice little booklet, the ANUM. This is our ECE, the Electrical Computer Engineering Department. We have a publication that tells you what's going on, and I'm sure there's a PDF available online. But anyway, on page 42, they list the 199 employers that our students have gone to in the past 5 years.
Okay.
So, some of them I know, like places like AMD and Intel have tens of students coming, and some might be just a single student. But so there's, 199 employers over the
Don't
past 10
worry, we
years.
won't ask you to list all.
Aye,
of them.
exactly.
Great. Well, maybe, and I don't know if maybe your book has this, and hopefully the list isn't that long. But where are the graduates going, Professor Draper?
So I guess one measure is so the graduates of mine who've worked with me, say, in my
Yep.
design projects. So the ones who went on to graduate school, so one is here working with me, one is at McGill, one's at Stanford. So those are the three over the past 2 or 3 years. The others, lots of them have been actually RBC, so finance, AMD, which is a semiconductor company, so kind of
Okay.
across the tech sector. Yeah,
So
I think.
lots of opportunities.
Yeah, I think, don't know that I really know any graduates who don't have good opportunities, I
Yeah.
have to say, in this discipline. Yeah.
And I mean, it's a very versatile degree, right? I mean, just from listening to both of you giving examples of students going from research to work opportunity, different sectors. So it seems like a really great opportunity to explore for students, even not really knowing what they want to do, right now. It also looks like we have a few questions that have come in. So
Great.
if both of you are okay with this, we'll dive on into that. The first question a student's asking is, may I ask about the employment rate for computer and electrical engineering students? And I mean, another question was, what are some of the possible future jobs? That we already touched upon. I know that for
Good.
engineering students, it's about 88% after 6 months and 93% after 2 years. But that's a whole general for engineering students, and that's a little bit of a dated, I think within the last 2 years or so, I'm sure that has shifted a bit in the past years. I don't know if Professor Draper or Shirs, you might know specifically for the electrical computer program.
So I've heard numbers, and I didn't bring them with me, but they
Yeah.
sound reminiscent of that. And I seem to remember some of those numbers we hear also does not count students who were, for instance, in graduate school,
That's
because they don't
correct.
count towards employment, so they're counted as unemployed, I guess,
Yeah.
even though they may be getting paid. It may also doesn't count people who are doing not-for-profit work. So I think some of those numbers, it may be even higher. But I kind of remember
It
that
could be skewed,
high
yeah.
80s, low 90s number.
And
Yeah.
I mean, even to go back to the internship opportunities, Choice is a perfect example of someone that had the opportunity and got rehired back on, right? And you haven't even graduated yet, so you don't even know the potentials you might have with this company after you graduate. So to even say that a lot of our students have jobs coming back into fourth year even before they graduate, so that's a great thing to mention as well to the students that are wondering.
I think it's about 2/3, isn't it?
That's
So about
correct, yeah.
2/3 of the PUIs have offers
Yeah.
for full employment
Yeah.
upon graduation.
And for PUI, there are more job opportunities than there are applicants.
Totally.
So when you do a PUI, you usually get a job offer to come back later on.
Yeah, of course. You just got to put the effort in.
Mhm.
Yeah.
I'm not sure if we said, but there is an office that helps bring in those opportunities,
yeah.
helps with the placements, the interview process, and there's another office that helps with summer co-ops,
Yeah.
so which not separate from the PUI office.
Exactly. And the nice thing about all of this is too, it's optional, right? So sure as you probably
right.
didn't really know your exact route when you first started in first year, right? So to have these opportunities and the flexibility down the road was probably peace of mind, right?
Yes, most
Absolutely.
definitely.
So it looks like we have another question that has come in, and the question is, what would be some possible jobs if I were to specifically focus on computer hardware?
So, do you want me to list, or do you want to go over it?
We could both go first.
Okay, so I mean,
Too
one of the
nice.
companies I work with, I mentioned AMDs. They do like chips, like the multimedia groups. They build processors that like make your video game consoles run faster. In computer architecture, you could also go to like Google is building new architectures for machine learning. I'm trying to remember their name right now, the name of their processor. Anyway, so there's lots of also Intel recently purchased Altera, which is an FPGA field programmable gate array. So they're trying to merge these, which are reprogrammable hardware, onto the chip that has also a CPU on it. There's also stuff like IBM, and a couple of years ago came out with a new processor that does spiking network. So it's kind of to have a processor that works more like the brain. You could go to my collaborators at Analog Devices. So there's lots of places where there's lots of actually very interesting stuff going on in computing right now, and computer architectures to make things smaller, lower energy, embedded for Internet of Things and learning kinds of applications. So I think computer architecture is a great field. So
There's also NVIDIA and
Yep.
companies where all over the world actually
Yeah.
that make computer chips for everything. So yeah, it's actually a really good field, and I'm doing that. So.
Yeah. So you're not biased at all,
I'm
right?
not biased at all.
Well, it looks like we don't have any other questions from the chat. But to finish off the night, any words of wisdom from either or both of you for our audience?
I'd say the biggest thing with engineering is the concepts and everything is important, but the biggest thing is learning how to learn.
Yeah.
Learning things from scratch, and actually learning how to learn is actually a really important thing to learn.
Yeah.
Because that's one of the biggest things that I've learned here at U of T. Another thing is time management, and those kinds of skills that you build here is what is really important in engineering.
Yeah. And it transfers into.
It transfers into the industry as well, and in anything that you do, research, industry, or even in your life maybe.
Yeah, for sure.
So yeah, I would echo that. Actually, I've been asked by students that we have the Ontario Universities Fair here for people in Ontario that know what that is, where lots of high schools come together. And one question was asked by a student once was, how do I best succeed at U of T? So I had to kind of think about that, and then I kind of realized, oh, yeah, it's basically what you said. It's easy to work. It's easy to work hard, and you get lots of work to do here. So the trick is to learn to work smarter, and always think about what you should be doing and what's kind of the idea. What's the fundamental concept that your classes are trying to do, or what's the fundamental bottleneck in this programming, assignment, and how do you build the right architecture so you can architect the right solution. So that kind of learning how to learn, that kind of thinking deeply about the problem to get at the fundamentals is, I think, the way you would be most successful both here and yes, later in life too.
Definitely. And I would echo that as well. And you'd be coming to a faculty that's very similar on the administrative side, faculty side. The students are very collaborative, so it's a very nice environment. So definitely, if you're considering engineering, highly some research on our. I'm sure that you've learned a little bit more about this tonight. I thank everyone on behalf of the faculty of Applied for tuning in tonight. Any other questions? My colleagues are email offline. Other questions, or even just want